Hi students, this is the third lesson of electrostatics. In this lesson, we will discuss about the principle of superposition of Coulomb's law. The previous lesson, we discussed about vector form of Coulomb's law. According to the principle of superposition of Coulomb's law, in a system of charges Q1, Q2, Q3, etc., the net electrostatic force acting on any one of the charges is equal to the vector sum of electrostatic forces acting on it by the other charges individually, irrespective of the presence of other charges. That means, suppose we have three charges here, Q1, Q2, Q3, with the position vectors R1, R2 and R3 respectively. Then suppose we take the charge Q1, there will be a force exerted on Q1 by Q2 and as well as by Q3. So the force exerted on Q1, the net force exerted on Q1 will be the vector sum of the force exerted by Q2 and force exerted by Q3. The force exerted on Q1 by Q2 will be in this direction, that we can write as F12. So F12 is the force acting on first charge, that is Q1, by the charge Q2, and this will be repelling because both of them are positive charge, so it will be repelling this direction. And the force exerted on Q1 by Q3 is this one, F13. It is in this direction because it will repel in this way, and the total force, the net force acting on Q1, we can obtain by adding this vector F12 and this F13 by using vector addition method, either by using parallelogram law of vector addition or the triangle law of vector addition. If we use parallelogram law of vector addition, these two vectors, this is the force on the Q1 charge by Q2 and this the force on Q1 charge by Q3, and if these two vectors, if you consider as two adjacent sides of a parallelogram, then the resultant will be the diagonal drawn this direction. So the diagonal drawn this direction will give the resultant force acting on Q1 and because of the two charges Q2 and Q3. The force exerted on the charge Q1 by Q2, that can be written as F12, that is equal to, if the charges are placed in vacuum, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught into Q1, Q2 divided by R12 square. To get the direction, we will take R12 cap. R12 cap is a unit vector moving from Q2 to Q1. Q2 to Q1, that is this direction, that is the direction of F12. The same way, the force exerted on the charge Q1 by Q3, that force can be written as F13 vector is equal to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught Q1 Q3 divided by R13 square of that, R13 square into R13 cap. If there is one more charge, that will be fourth one, then F14 will be equal 1 by 4 pi epsilon naught Q1 Q4 R14 square into R14 cap, etc. This will come, and finally the net force acting on the charge Q1 because of these two vectors can be written as, if F1 is the force acting on Q1, the net force acting on Q1 because of the other two charges, that can be written as the vector sum of F12 plus F13. If there are more than three charges, then we can write plus F14, F15, etc. That will give the total force acting on etc. That will be the total force acting on the charge Q1, and this can be once again written as F1 is equal to, in this case we have total 3 charges, then the force acting on the first charge Q1, that is F1 is equal to, we can substitute for F12 and F13 here from these two equations. In these two equations, 1 by 4 pi epsilon naught is common factor. 1 by 4 pi epsilon naught is common factor. 1 by 4 pi epsilon naught is taken outside the bracket. Then inside the force exerted by the charge Q2 will be Q1 into Q2 divided by R12 square into R12 cap plus the force F13 we can substitute it as Q1 Q3 divided by R13 square into R13 cap. If there are more forces, if there are more charges, again we can add like this, plus Q1 Q4 divided by R14 square into R14 cap, etc. That will give the total force acting on the charge Q1 because of the other charges. Hence finally we can see that the net force acting on this charge Q1, when we consider the net force acting on this charge Q1, first we will take the charge Q2 and we will find the force between Q1 and Q2. The presence of Q3 will not influence the force between Q1 and Q2. So we'll just think about that Q3 is absent, it is not present over here, and we'll calculate the force between Q1 and Q2 separately. Then when we consider the force acting on Q1 by Q3, then we'll consider Q2 is absent, Q2 is not present here. It means the presence of Q2 will not influence the force between Q1 and Q3. So we can find out individually the force exerted by each charge on Q1 and finally add them by vector addition method. That will give the total force acting on the charge Q1 in this system of 3 charges.